All right, so your quiz covers 6.3, 6.5, and 6.6. 6.3 was the piecewise functions, 6.5 is the operations on functions, and 6.6 was the inverse functions. So I'm going to go through each section and kind of like highlight the topics that you need to know, maybe throw in an example there, whatever you guys need. And then the quiz review, I think I posted right on the quiz. I'm confirming that now. There's no calculators. I think there's 10 questions. You haven't used them all week. You don't need them. It's not hard numbers, okay? So in 6.3, we talked about piecewise functions. And these were the ones that different functions have different parts based on what the value of x is. So they can look like something like that, okay, where you've got different functions based on the value of x. And you're going to do two things with this. One is graph it, and the other is evaluate based on a value. So if I'm to graph this, remember I said there's kind of two options. You can either plug in points from each range. So if I was trying to graph this first one, the y equals 2x plus 1, I can plug in values starting at 1. I want to include 1 because I want to know what happens there, and then less than 1. So I can do like 1, 0, negative 1. With the line, it might be just as easy to just draw your line and then erase what you don't need. So if I'm going to graph the first one, let me graph it in a different color. I would start at positive 1 because that's my y-intercept, and then I'd go up 2 and to the right 1. And then because it's less than or equal to 1, I'd go to where x is 1. It's an or equal to, which means solid dot, right? Open dot would be if it's less than or greater than, not or equal to. And I'd keep the line here to the left. God bless you, because it's less than. Yeah.
Can you go over the solid and open dot thing?
Yeah, so if this had said less than and not less than or equal to, I would have given it an open dot.
Okay.
Or equal to says solid dot. And then if I wanted to graph y equals 2x squared plus 3, so a quadratic could be where it's a little bit trickier because you can't find exact points other than the vertex. So I know that's a parabola, right, because it's squared. And I know plus 3 does what to my parabola? Shifts it up 3. But then I've got a 2 in front, which I know vertically stretches it, but you don't have exact points. So my advice would be to plug in points for your parabola. So I would take values starting at 1. I would still use 1 even though I know it's going to be an open dot, but I need to know where that open dot goes.
How many graphing questions?
There's one like this, and then there's the inverse. And then I would go bigger than 1 because it's greater than 1. So 2 and 3, and plug those values in. So 2, 1 squared plus 3, which is 5, and then plug in 2.
11.
And then plug in 3. Should have picked smaller numbers. Karina. Why say that again? Because I need to know where that, I know it's going to be an open dot, but I need to know where that open dot goes. Because it is still a point, it's just an open point. So I would go 1, 5, 1, 2, 3, 4, 5. This is an open dot. 2, 11, so you're going to go higher, and 3, 21 is going to be even higher. So this is a parabola, and this is just the right side of it coming up. So it's not a straight line. It would be curved because it's a parabola. No, the other points should still be solid because they're less than, Oh, the ones like along the parabola, you mean? No, these are all solid dots. The only one that's what would be open is the first one where the x is, or sorry, I'm pointing at the wrong one. The only one that would be open is the first point, which in this case is 1, is where x is 1. Everything else is greater than it, so it counts. It's just that 1 gets the open dot.
So then, in the other graph, why aren't those open dots?
Because it said or equal to. So or equal to says include 1. Include where x is 1. Does that make sense? So if remind me, I'll go back to it, I'll do another example, okay? But while I've got this one pulled up, because the second part of this is going to be to evaluate it. So it'll say like evaluate the piecewise function where x is 2, let's say.
Then it would be 2x squared plus 3.
Good. So the 2 tells me to pick the second equation because 2 is greater than 1, and then plug 2 in, which we actually already did. We did 2, and we got that it was 11.
Okay, so if we say evaluate x is equal to 2. So
We're doing f of 2 is what you're doing.
Okay.
So that the range tells you which one to use. In this case, 2 is bigger than 1, so I use the second one. God bless you. And then I'd plug it in.
Okay.
If you already plug it in, you don't have to do the extra work. But if you didn't, then you have to do that. So if I said x equals 1, which function am I going to pick, the top one or the bottom one?
Top.
Top one. Does everybody understand that? Because it's less than or equal to. So then this would be 2 times 1 plus 1, 2 plus 1, which is 3. Ian?
Well, I remember you were saying something that you were teaching us a lesson about, like, if like an open and a solid dot are on the same coordinate.
Right, if they overlap, then it becomes solid. Because one would make it solid, the other one would make it open, but the solid takes over the open. Yeah. So let me do an extra example. I had so x squared plus 2 if x is greater than or equal to 0, and x plus 2 where x is less than 0. So what shape does the top one typically have? Parabola. It would be shifted up 2 places. So I'm not going to plug in the points, but so you can get an idea. This would be shifted up 2 places. If I had plugged in 1, I would have gotten 3. If I had plugged in 2, because I'm saying greater than or equal to 0, 2, I would have gotten 5. So this parabola would look something like this. And it's greater than or equal to, which is why this dot is solid. So then the next one, y equals x plus 2, is what kind of graph? A line. So I'd start at 2, and I would have gone up 1 and over 1, up 1 and over 1. So it would have been a line that looks like this. But I only want it for the values that are less than 0. So I would erase this. And technically, the blue graph would have been an open dot. But because they overlap, it would be solid. Does that make sense?
So
Okay.
So in our tests, we don't, if there's an open dot that overlaps a closed
Then
dot,
it's a solid
just
dot.
leave it.
Yep, only if they're on separate, God bless you, only if they had separate y values would they be open and closed. Questions on piecewise? So that's it, what you have to do for piecewise. Okay, so 6.5 was the operations on functions. So this is if you're given an f of x, a g of x, and it asks you to find the sum of them. So it could say f plus g of x. It could say f minus g of x. It could say f times g of x. The good news is division is not on your quiz. It might be on your test, but it's not on your quiz. And then we also had composite functions, f of g of x, g of f of x.
When this is f of g of x, you have to solve for g of x first and then plug it into f of x?
So if it is just an x, then you literally just take g of x, as it is and plug it into f of x.
Mhm.
If it gives you a number, which I'll show you an example of that, if it gives you a number, then yeah, you start in the innermost and then go out. Mhm. All right, so let's say that this is f and g. F of x is x plus 2, and g of x is 2x plus 3. So if you're adding them, you simply want to combine like terms. This would be x plus 2 plus 2x plus 3, which is 3x plus 5. So you might see a squared in there. Okay, just combine your like terms. If it was minus, so I do the first one, which in this case is x plus 2, minus the second one. And this is the one you got to make sure that you change the sign of everything in the second one. So this becomes x plus 2 minus 2x, oops, I wrote equals, minus 2x minus 3. And then combine your like terms. Negative x minus 1. Questions so far? Okay, then you have f times g of x, so you just multiply them. And you're multiplying binomials, so you FOIL it. 2x squared plus 3x plus 4x plus 6, and then combine your like terms.
Do we need to simplify?
Well, by combining like terms, you're simplifying. You mean factor it back out?
Yeah.
No, because that gets you back to the original.
Okay.
Yeah. It's technically more simplified when it's expanded. Questions on those so far? Ian?
Can you do the subtracting again?
The subtracting? Yep, so I took the first one, so pay attention to the order of the letters. This says f minus g. So I took f, and I subtracted from it, which is this, all of g. And this is where you got to make sure that that minus goes to every term that's in g. And then combine your like terms. Okay, then you have your composite function. So f of g of x means take g of x, whatever that value is, which in this case is this expression, and plug it into the x value on f of x. So this would become 2x plus 3 plus 2, or 2x plus 5. So I took the g and plugged it into the f, innermost parentheses first. Yep, but you got to pay attention to the order. I should group it first. Okay, and then the next one is g of f of x. So this time I'm taking f of x and plugging it in to the g. So this would be 2 times x plus 2 plus 3. Distribute the 2. And combine your like terms.
Wait, so if the G's inside the parentheses, it goes into F?
Yep.
And then the F is in parentheses.
Correct. And then the last kind with this was if you had something like f of g of 2. So this time you're taking the value of 2 and plugging it into which function first? G. So I'm going to take and find g of 2 first, which would be 2 times 2 plus 3, or 4 plus 3, which is 7. And then I find f of 7. So I take 7 and plug it into the f. 7 plus 2, which would be 9. And the last one is your answer, so it's not a two-part. So go innermost parentheses out, take the 2, plug it into the g, get a value, take that value, plug it into the f, and what you get from that is your overall answer. Just pay attention, because it could be f of g of 2, it could have been g of f of 2, and you would have had a different answer. So the answer would have been 9. Ian?
Oh, okay.
You sure?
Yeah.
Yeah? Everybody else okay? Anybody still copying it down? Okay. And I'm going. So inverse is a function. So this is kind of all looped into two questions. Okay, one is using the horizontal line test.
Wait, when do you use the vertical one?
To see if something is a function. So you won't need it. You're just going to end up showing. So if I gave you a graph, if you wanted to see if that graph was a function, you'd use the vertical one. If it's asking if the inverse of that function is, which is what it's going to ask, that's when you use the horizontal line test. So if I have a graph, actually I should make that better curve. Okay, if my graph looks like this, the horizontal line test is going to tell me if the inverse of this function is a function. So this would be like a cube root function. If I would draw horizontal lines through this, would it hit any of those lines at more than one point? No, so then the inverse is a function. If my graph was a parabola, which would be a function in itself, that would the inverse of this be a function? No, this time the horizontal line is going to hit it more than once. Okay, so that one's a simple yes or no. And it says use the horizontal line test, so you can't confuse it. You just got to know what a horizontal line is.
Minus interruption.
All right, and then the last part is find the inverse of a function. Is the inverse a function? And then find its domain and range. So if I had y equals 7x plus 1 as my initial function, actually it would have been f of x, not y. F of x equals. So we remember the steps to finding the function?
Replace f of x with y,
Good. And then
and then replace x and y,
switch the x and y. Good.
and then solve for y.
Good. So I'm going to first, this is a y equals 7x plus 1. Then I'm going to switch the x and the y. And then I have to solve for that new y. So, and then divide by the 7. So I get x over 7 minus 1/7. God bless you. Ian.
What lesson did you first learn that in like that?
The very first time? Ooh, I'd have to look back. It's in chapter 4. Remind me before we leave and I can look at the exact lesson. Okay? And then the last thing we would do is f negative 1 of x. Because it's not y, it's actually f negative 1. So I'm showing the inverse to it. So this is the inverse. Okay? That's the first part. Then the question is it a function? So to figure out if it's a function using that horizontal line test, I'd have to graph the initial one. So I'd have to figure out what the graph of this looks like. So 7x plus 1 is what kind of a graph? It's a line. Good. Start at 1, go up 7, 3, 4, 5, 6, 7, and over 1. Would this pass or fail the horizontal line test?
Nope.
A line would
Would pass.
pass it, which means that the inverse is a function. So yes, this is a function. And then we want domain and range. So for the domain of the inverse, which is this one, we look for the same two restrictions we've been talking about. So the restrictions on domain are variable in the denominator. In that case, we would set the denominator not equal to 0. And variable under square root. So are either of those things happening with my inverse? No, which means my domain is all real numbers. Okay? For the range, yep, so the domain, so let's say that like if you look at this inverse, there's no variable in the denominator. If there was, then I would say that that could not equal to 0. And that's how we set up our restriction. Restrictions equal domain, same thing. And then the other case is if the variable's under a square root. So if the variable's under a square root, there would be a restriction on the domain. To find the range of the inverse, we look back to the original function. So we go back to this one, and we find the domain of that one, right? Because the domain of my initial becomes the range of the inverse. Does that make sense? So if I look at 7x plus 1, do I have a variable in the denominator or a variable under a square root? So what would be the domain of f of x? All real numbers, which means the range of f negative 1 of x is all real numbers. So the domain from the initial one becomes the range on the inverse. Does that make sense? Okay. We did it, right? The bell's about to ring. That's it. So that's what's on your quiz. So I'm going to post the quiz review directly on the quiz assignment. There's no submission because the answers are going to be posted, okay? Tomorrow when you come in, I'll go over questions, a couple of questions if you need it, on the quiz review, and then you'll take your quiz the latter part of the class period.